Hello, hello. Welcome to your first flip learning lesson. This is Ms. Lehner here, and I will be your host for today. So, follow along in your notes and listen carefully. Today, we will be learning about order of operations. Okay, in most languages, the meaning of words depends on the order. For example, you can see right here, sign the check is not the same as check the sign. The order of those words matter. Order also matters in other things. For example, a recipe. Sometimes order doesn't matter. But when you're making a peanut butter and jelly sandwich, it really does. First, you need to put the bread down. Then you need to spread peanut butter and jelly. Then you need to put your sandwich together. That order is really important. If we change the order, would we really get a good peanut butter and jelly sandwich? I don't think so. I've just created a mess on my counter. So, is the order we do things really important? I'll let you answer that for yourself. Now, the order of operations tells us how to do a math problem with more than one operation in the correct order. Let's take a look at an example. If I solve this problem from left to right, 3 plus 5 times 4 divided by 2, well, 3 plus 5 is 8. Copy the rest down. 8 times 4 is 32. And 32 minus 2 gives me 30. Okay, so I have an answer here. Let's try solving it a different way. Starting with my original, let me solve it backwards. So 3 plus 5 is going to stay. 4 divided by 2 gives me 2. Okay, now I'm going to solve the back end again. 3 plus 5 times 2 is 10. And 3 plus 10 gives me a 13. Wow, I got completely different answers. So, this shows me that there has to be a specific order in order to solve. If I solve in any order I won't always get the same answer. And there's really only one answer. That brings us to our order of operations. You may already be familiar with PEMDAS. We often use this phrase, "Please excuse my dear Aunt Sally," to remember the order that we need to solve and simplify expressions. The P here stands for parentheses, the E stands for exponents, M and D mean to multiply and divide left to right, A and S mean add and subtract from left to right. We're going to expand on that. Now we're going to use GEMDAS. E is still exponents, M and D, we still multiply left, right, A and S, we're still adding and subtracting. But now, instead of a P, which only talks about parentheses, we're going to use a G to talk about all grouping symbols. So, to help us and look at these symbols, we're going to fill in this pyramid with all the different symbols that we may see and what needs to be done at each step. So in the first top tier here, we're going to fill in our grouping symbols. Underneath, we'll put all our exponents. Below that, we got our MD for multiplication and division. And finally, our AS for addition and subtraction. So, take a moment here, pause your screen, and fill in these symbols where you think they go. Take a moment, pause this video, and sort all of these symbols into the categories you think they belong. Fill them in on the pyramid in your notes. Alright, let's take a look and see if you got everything right. Up here we have our grouping symbols. You can see some parentheses, curly brackets, regular brackets, and this long bar. That's used to put a lot of operations on the top or the bottom of a fraction. Our next category, we have our exponents. Basically, anytime you have a small number in the top right corner, that's an exponent. Next, we have multiplication and division. Notice how I filled in the symbols in various orders. You always multiply or divide from left to right. So if division happens to be the most left, you're going to divide first. If multiplication comes first, that's what you do first. Notice this star symbol in the bottom right corner. That's called an asterisk, and that's how we type multiplication on the computer. Right next to it, we have a forward slash. That's how we type division. Finally, our last category, we have addition and subtraction. Now, you only have two symbols, but I decided to repeat it a bunch of times. Just to show here again, we solve from left to right. If this subtraction happens to be the first thing on the left, it's the first thing I'm going to do. This is another way that you can look at GEMDAS. Sometimes we like to stack up our symbols, our letters here, to help us remember grouping comes first. Once we've done everything inside our groups, we move on to exponents. Then we multiply and divide left to right. And finally, when all that's done, we can add and subtract from left to right. Let's take a look at some examples. This one is given to you. If we look at this problem, the first thing we need to look to solve, to simplify, is a group. We can see our groups right here with our parentheses. Now, when you go inside a group and begin to simplify, you need to use the order of operations there as well. So inside my group, I see addition and subtraction. That means I'm going to use addition and subtraction from left to right. The leftmost one is addition. So the first thing I did was in my group, I added. Now, on my next line, I still have a group. So I still need to be looking at my G category. Inside my group, I can see subtraction, 15 minus 18. So I subtract, I use my rules, boxing here, I box the number, I box what's in front, and I have a 15 and a negative 18. Different signs, I subtract. The larger sign's the 18, so my result here is a negative 3. Now that I've solved everything inside my group, I'm left with just one number. So, My G is complete, and I can look for exponents. I see no exponents, so exponents are good. Now I look and I have multiplication and division from left to right. Well, the leftmost thing I see here is 33 divided by negative 3. So, I use my faces. Positive, negative. That's a frowny face. And as I divide here, I get a negative 11. Finally, I'm left with just negative 11 times 6. I can multiply, and I get a negative 66. I didn't even have to use addition or subtraction. The next few examples, you should pause at the beginning and try them on your own. Then use the video to check to see if you are correct. So, take a moment here, pause, and try A by yourself. Alright, now that you've tried this by yourself, let's go over it. Order of operations. We have G, E, M, D, A, S. GEMDAS. So first I look for groups. I see some parentheses, but each parentheses has exactly one number inside. So those are not groups, and I do not need to look at those. Next I look for exponents. There are no exponents, so I can check that off as well. Now I can multiply and divide from left to right. Reading this, 16 divided by 2 times negative 4 plus 7 times 5. 16 divided by 2 comes first. So 16 divided by 2 gives me an 8. And I still have the rest of my problem. Next, left to right, now I have some multiplication. I have 8 multiplied by a negative 4. Multiplying, I get a negative 32. My rules tell me that that must be negative. Now, I still have one piece of multiplication here, so I'm not done with that row. And next I need to multiply my 7 times 5. So I still have a negative 32, and 7 times 5 is a positive 35. Multiplication and division is all done. Lastly, I can add and subtract left to right. So all I'm left with here is a negative 32 plus 35. Using my rules, I'm going to box these off. I can see this is a negative, my negative 32 plus 35, that means that's a positive 35. Different signs, I subtract. 35 minus 32, that's a 3. The larger number is 35, so my answer is positive. Positive 3. Good job. Now let's look at example B. Take a moment to pause and try this on your own. Alright, now that you've tried it on your own, let's go over. First, GEMDAS. I've written in the top corner to remind me to follow these steps. I need to start with groups. So the very first thing I'm going to look at is my group. Now this group has a lot inside. I have 17 minus 15 plus 4. Inside, I need to use my order of operations. There's no groups inside, there's no exponents inside, there's no multiplication or division, so I can add and subtract from left to right. Starting with 17 minus 5. That's some subtraction here. So my first step gives me a negative 3 minus the quantity. 17 minus 15 is a 2. I still have my plus 4. Close my parentheses to the third power divided by 4. This is a complicated one. Now, looking at this again, I still have a group. I still have these parentheses with some operations inside. So inside my group, I see addition, and that's going to be my next step. So we have now negative 3 minus 2 plus 4, that's a 6. Notice how I keep these parentheses. That can help you avoid some errors. All divided by 4. Now, I'm done with my groups. There's only one number inside my parentheses, so that's just a number. Next, I need to look at exponents. This time, I have an exponent. I have this third power here. Now, to the third power means you multiply a number by itself 3 times. So if I have here positive 6 to the third power, I'm going to look at 6 times 6 times 6. 6 times 6 is 36. And 36 times 6 and 36 times 6 gives me 216. Whew, that's a big number. So this step now I have a negative 3 minus 216 divided by 4. Okay, that was my only exponent, so I can check that off. Now, multiply and divide from left to right. I have negative 3 minus 216. That's subtraction, so nothing there. But 216 divided by 4. So my next step is going to be divide. 216 divided by 4 gives me a 54. So now I have negative 3 minus 54, and I'm done with my multiplying and dividing. Check that off. Last step, add and subtract. So using my box method, I have a negative 3 plus a negative 54. Same signs mean I add. 3 plus 54 gives me a 57. And they're both negative, so my final answer is a negative 57. This final example uses a large fraction bar to show many operations on the top in the numerator and some more operations in the bottom in the denominator. Pause for a moment and try this problem on your own. All right, good job. Let's go over to make sure everyone's good. Now, since this giant fraction bar is separating many operations, that means we have a full group on top of the bar, and we have another group on the bottom. First, we're going to solve everything that is on top in the numerator. So, our first step is Inside my group, I see I have an exponent. So inside my top group, my numerator group, I'm going to focus on my exponent. I now have 12 plus 4 squared, or 4 to the second power. That meant 4 times 4. 16 minus 10. Okay, I'm not done with that group yet. So in my group, I look for multiplication and division. There is none. So I can add and subtract from left to right, starting with my addition on the left. 12 plus 16, that's a 28. And I am left with 28 minus 10. Finally, inside my group here, I have just one operation. That is subtraction. And 28 minus 10 gives me an 18. That's my numerator. Now let's look at my denominator. Here in my denominator, I can see I actually have another group. So my denominator is a group. Inside my denominator, I have another group, 1 plus 10. And inside that group, I have addition. Remember, you have to follow the order of operations when you are inside a group. So, inside my group was a second group, then some addition. I simplify, and I get 5 minus the 1 plus 10 became 11. Now I just have one operation. So still inside my denominator, still inside a group, I'm going to subtract 5 minus 11. If we box, we have a positive 5. Minus 11 means negative 11. So now, different signs, I subtract, and I get 6. 11's bigger, so that's a negative 6. Now, we have finished our groups. We had 2 different groups. But there's one last step. After solving my numerator, I have an 18 with this fraction bar, and in my denominator, I have a negative 6. This is not fully simplified yet. 18 over negative 6 means I need to divide. So there are no more exponents, but I still need to finish my multiplication and division from left to right. Final step, divide. 18 divided by negative 6, different signs. That's a negative answer. And 18 divided by 6 is 3. So your final answer, using order of operations, is a negative 3.